Okay, here I pop up again the probability tables that we just derived before. Now I want to calculate the probability of having a kick movement in the fourth action, given that we have kick in the first action, punch in the second action, and punch also in the third action. So how to do that? You know how to calculate this probability? This probability is calculated using this relationship. Where is it coming from? This is coming from the chain rule, right? If you need to refresh your memory again, please go to the previous video where we discuss about chain rule. So sorry, what happened? Okay, having this relationship of this probability, we can calculate the probability of kick having kick punch in the first reaction. From here we know that the probability of having kick in the first action, given that we have a kick in the fourth action, we can find it from this table. So class of kick when we have action 1 is kick, when we have a kick in the class, will be equal to 25%, 1/4. So this will be 1/4. And then the probability of having punch in the second action, given that we have kick class, will be equal to a punch having kick class, also 1/4. Probability of having punch in the third action given kick class will be equal to half, 2/4. And then we multiply it with probability of kick, which is 1/3, 4/12 here. We multiply all of them and then we get this number. So this will be the probability of having kick given kick punch in the first reaction. Okay, and then we do it again for the remaining two probabilities. We calculate first the probability of spatial action in the fourth action, given that we have kick punch in the first three actions. So same like before, we use this chain rule formula there. The probability of having spatial class, having a spatial move in the fourth action, given that the first reaction is kick punch will be equal to this multiplication, right? So we find first the probability of having a kick in the first action, given we have a spatial class. Spatial class, first action is kick, so we have 1/3. Probability of having punch in the second action, given we have a spatial class. Spatial class, we have punch, is also 1/3. And then the probability of having punch in the third action, given spatial class, is 2/3 here, right? And then the last one, we multiplied with the probability of spatial class, which is 1/4, 3/12. We calculate it, we get this number. The last step, we calculate it for punch. So we calculate the probability of having punch class, given that we have kick punch in the first three action. So same like before, we calculate these four probabilities, and then we have the probability equal to 0.02. Comparing all of these three probabilities, 0.0104, 0.0185, and 0.02, it is clearly that the largest one, the largest probability happens to be punch in the fourth action. So based on this analysis, we estimate with the highest confidence that the fourth action, having the first three actions are kick, punch, punch, will be punch. Okay. Now let's take another example. I want to estimate again what the fourth action be, knowing that the first three actions are kick, special, special. Same like before, this is what we can do. We derive the probability tables there, and then we calculate the probability of class kick, given we have kick, special, special as the first three action, probability of having class special, having kick, special, special as the first three action, and probability of having a class of punch, given that we have kick, special, special in the third first actions. So from this calculation we get this number 0.010417 of having a probability of kick, having kick, special, special as the first three action, but we have 0 and 0 in the last two probabilities. So from here we conclude that the highest probability will be kick in the next in the fourth action. But looking at these numbers, I have one question then here. Because the probability of, let's take a look at this special case. Because the second action, let's take this case for a special class, having a special as the second action, the probability is 0. Same to this case also. For a special class, the probability of having special in the third action is 0. Can I say that? Does it mean that if the second and or third action is special, regardless what the other actions are, then the fourth action will always be special? Will never be special, because the total probability will always be 0. Yeah? So whenever we have this or both, then the probability will always be 0. Does it mean that if the second or the third action is special, does it mean that the fourth action will never be special? So this might be a bit taking our attention a bit more because of this 0 probability. This is something that we can discuss in the next example.